Hello guys, in this version of tutorial video we will see how the player interacts with the platform. In the last video I created this platform as a prefab and I have created this line renderer and I explained how this works. One thing I wanted to tell is I said in last video I won't be manipulating the z-axis, but I did here. I kept it minus 0.1 for red and blue, and for yellow and green I kept it minus 0.05. This is just to make sure this line renderer will be rendered on top of the sprite. So with this setup, how it will look like is our red and blue will be rendered first because it is at minus 0.1. If you see in 3D view, you can see very clearly. So if I keep red and blue forward, so let move forward. So red and blue is like this, and yellow and green comes behind red and blue, and at last comes our platform sprite. So we do this so that in 2D view, if you see, it gives the illusion that line renderer is getting rendered on top of our platform sprite. So that's the reason I kept this value little bit forward in z-axis. So I kept for red and blue minus 0.1 and for yellow and green minus 0.05. So it looks like this. If you guys keep it at 0 also, it's fine, it will work good, well and good, but this is how it will look like, but I don't want that. So let's do Control Z. That's it. Now it is set up. Okay, so at runtime anyway these things won't be needed, just wanted to clarify this thing before going forward. So that's it. Now let's go and see how our player interacts with the platform, whatever platform we created. So one thing is I already created a sample scene where you can see the output. Okay, let me show you the output, what you will be getting at the end of this video tutorial. So first we will see it, then I will explain how it is done. So this is our platform and it works really good. So now, yeah, so this is the output you will be getting at the end of this video. All this platform, if you see here, it's just a prefab. I am actually taking this input and I am giving to the player, and player does some calculation and the collision happens, and Unity physics engine is taking care of collision and other things. So I had already done the setup for the player and the platform. Couple of things I already did because it's kind of little bit long process, but still I will explain you what are all the setup, what are all the setups that I did. All those things I will explain you so that it will be easy for you guys to understand. So first thing is, let's make this player as a prefab, then it will be easy. Open the prefab. If you see and make okay, now the player is kept at 0.725, make it 0 0 0. So now the player is at origin and keep the scale of 0.1 0.1 0.1. Actually z-axis scale is not needed, but still I kept it 0.1. And add a rigid body to this empty game object and tick simulated, give collision detection, continuous sleeping mode, start awake, and make sure freeze rotation in z-axis is checked, because this character will be rotating, but we won't be rotating this game object, that is this player, we won't be rotating. Instead we will be rotating this sprite. So this is the sprite, we have this yin yang symbol, this is the this game object is the one we will be rotating. So just make this freeze rotation, so that this, when we do this, we say this game object has rigid 2D body attached, and physics won't take hold of rotation. So rotation will be freezed and we are free to do whatever we want. And just add a circle collider and make sure you add a physics material. So there are two types of materials in Unity. One is 3D physics material and another is 2D physics material. So what I did is I created one physics material called no friction, where I set the friction value to 0 and bounciness to 0. So whenever the player collider interacts with any collider in the world, there won't be any friction. So we made this material and we attached this to our circle collider, and here comes our player script, a meat of our all the work that happens with respect to player movement and everything. So I, before going into the script, I wanted to go under this game object and explain what are all these things. So if you see here, the first one, it's a head race, and second one is foot race, and third one is side left, side right, and the last one is player object. So I have scaled player object sprite in x 5.1, y 5.1, and z 5.1. So this is the scale, so you don't have to worry about this. So let's see what is this head race. So whenever the player is there in the environment, player can jump up. So let me bring you the scenario like this. Assume we have a platform like this, and we have a platform like this, and one more platform is like this, and one more is like this. Okay, let's make this a little bit bigger. Okay, and do like this. Okay, and keep it above, something like this. Now when the player jumps, the player can hit the ceiling. Once the player hits the ceiling, the player has to come down. If the ceiling is at very top, that is if it is height is more, and if the player jumps, it won't go still there, but still player will go up to some max height, then the player will come down. So this head raise, basically what it does is it checks whether this race, that is if you see here, let me disable other race. Okay, 1 second. Okay, anyway it is running in the code. Okay, let me disable the players. uh, Hold on. Okay, if you see here, we have kept all this race 1 2 3, 1 2 3 4 5 6 7. Okay, so if I enable the player script now, you can see the head race like this. Okay, let me change the color here. Head race will be red color, red, red, red. Okay, I think you guys can visualize it. Okay, so what it does is it will, if this, there are totally 7 head rays that we have kept it here, and if any of this rays hit the ceiling, that is if it hits the ceiling, the player will come down. Similarly, foot race is for checking whether the player hits the ground. When the player has the gravity, the player will be coming down, and this race will check this down race. So we have around 7 rays over here. If any of these 7 rays hits the ground, then it means player can move on the platform, because it means the player is on the ground and he can move. And for side left and side race, the right race is for checking with walls, collision with walls. So for side left race, if you see, we have these many rays, and if any of this rays hits the wall, then player will not be able to move forward. Same thing goes for the right side also. So these are all the rays that we created in the player script. Okay, so if I open a player script, uh, it's very big, but I will go one by one. We have this class called public class ray property, where we have this game object ray, public length, color, layer mask, string, raycast 2D. What we did is we created a array for all of this object. So we have created a public ray property array of head rays, foot rays, side left rays and side right rays. So we have created a 4 arrays, and now these things will be exposed in the inspector. So if you see, let's go one by one. We have this head rays. So this head ray, if you see, we have created an array of this class. So we are saying in inspector, I want 7 head rays, and it will create 7 element, and it will ask the first property that in each element that it asks is a ray object. Which is the object that you would like to use, it is asking. So we are saying here first. So this is the object, and make sure this game object forward vector, that is, if you see, the forward vector is pointing in this direction. So it is pointing like this, it is pointing like this, so it is pointing this blue arrow, it is like this. For foot race, the same, this blue arrow will be pointing down in this direction, and for side left it is pointing in this direction, and for side right it is pointing in this direction, because we use this forward vector to do the ray casting and check whether it hits the ground or wall or ceiling. So what we do here is we are saying this is a ray object for head, and we are saying the length of the ray, that is 0.3, and we are saying this ray color will be white, and head rays is basically collision. For head rays, what is the collision that we have to check for? So if you remember here, uh, blue is for ceiling. If you see here, blue collider is layer is marked as ceiling. So basically whenever the player is there, player top, that is this head rays, will check whether any of these rays hit the ceiling. If it hits the ceiling, it will fall down. So that is what we are doing here. So 1 2 3 4 5 6 7, so we have exposed all these 7 rays, and we set the collision layer to check is ceiling. Similarly for foot also, we have created 1 2 3 4 5 6 7, and we are saying we have to check whether this foot rays hit the ground. So ground layer is this one, that is the red color. So if you see here in this one, this is the ground. And for side left also, we have exposed all these 7 game objects, and we are saying we have to check uh, the collision layer to check is wall, and side right trace also we have to check for collision layer wall. So whether it is right or left, we don't have to care about that, we have to make sure whether it hits the wall. So if you see yellow and green, both of them are tagged with wall, and their layer is also marked with wall. So that's the thing that we are saying to this player game object. So that's what this thing does. Head race, foots, this thing. So next thing that we are going to see here is we are saying in hidden inspector process input, whether can we process the input for the keyboard or joystick. By default we keep it true, and this speed, public speed, basically this tells uh, the speed of player when given input. So if the player moves left and right, uh, in how much speed the player has to move, so this value will tell whether with how much speed the player will move. And this draw ray is for gizmos drawing. In C sharp unity scripting, if you see, there is one function that mono behavior gives us. So on draw gizmos. So let me go to documentation, on draw gizmos. Okay, so this comes in mono behavior class. So this will be automatically called. All you have to do is you say on draw gizmos. So basically, for what this will be useful is, see, you are able to visualize this race, head race, foot race, and wall race. So this side left and side race, all these race you are able to see in the same view. So all these things happens in draw ray function. So we are saying if draw ray is true, so in this case by default we have kept it true. If it is true, and this function will be called only on unity editor, we check if head race is not equal to null. We iterate through all this race, that is currently if you see head race, its length is 7. We iterate through all this rays and we check whether the ray object is not equal to null. If not null, then we set the gizmos dot color equal to head ray of I dot ray color. So in this case it will take the white color. So if I change it to red, see, the color changes. So for each of the race section, each race section you can change the color. So you can change the color for this. So foot race will become black, so this is will become black or blue or whatever you feel, but I had currently given for all the things white color. So it assigns the color and we are saying gizmos dot draw line. So what it happens is it will take the ray transform dot position and ray transform dot position plus transform dot forward into ray length. So what happens is this line is the one that draws the uh, ray line over here. So for example, if you take the first game object, okay, let's take the head ray, 0th element. So here our game object position is here. So we are saying draw the line. Draw line takes two parameters, from and to. So we are saying from this position to head ray dot transform dot position plus transform dot forward. So from this position take the forward vector. Okay, so when you do that, the position plus your forward vector multiplied by ray length. So we are saying the ray length is 0.3. So if I say, if I increase it, you can see it goes up to this much. So we don't want this much big ray, we want a smaller version only. So we have kept it 0.3 so it can check whether it hits the ceiling. So we are saying the transform dot forward, that is this forward vector multiplied by 0.3 will give you one scalar value, one vector value. That vector we are going to add with the existing position. So when you do that, you can see the rays getting drawn like this. So from this position I am saying extend this line in this direction up to uh, 0.3 length. So we are saying scale this line up to 0.3. So same thing we are doing it for all the things. So left, right, foot, trace and everything we are doing the same. So that's what it does here. We iterate through this and we draw the line. We do for foot trace, we do for side left trace, and we do for side right trace. So that's it. If you guys don't want to draw this ray, all you guys have to do is draw ray should be false and this won't be drawn. But anyway, at runtime when the game is running, we won't be drawing this race because that will cost performance. So we can write this condition application dot is playing is false. If the application is not playing, it means we are in edit mode, then we can see the race. So that's what it does. Now let's come to the next value, jump up speed. Basically this says in how much speed the jump should happen. For example, if you take this sample scene, when I press the space key, the character jumps. So this, when you say jump speed is 50, then the character will go up very fast. See, sorry, that is I have done wrong. We say jump up speed 50. See, it goes very fast. So I had given it 6, and there is one more variable called come down speed. So once the character reaches the max height, for example it goes up to here, then the character has to come down. So in how much speed the character has to come down? Currently I have given it 10. If you give 100, once the character reaches the max height, for example if you move this above and when you give it, see it comes down to the ground very fast, so which we don't want. So we are giving it 10, so that will make sure the character comes down smoothly. And jump up seconds, for how many seconds the character has to be uh, on the jump mode. So we are saying for 0.5 seconds the character will be on air, after that the character will come down. So this tells how many seconds the character will be on air. And player rotation speed is basically for this, whenever you move right and left this sprite rotates. Actually we are not rotating a player, like I said, instead we are rotating the player object. So if you see in the scene view, you see the rotation. We are, so if this rotation is 10, then it will rotate very fast. Still it's rotating, make it 100. You see, make it 400, it will rotate slow. But 800 is pretty good value, so it rotates. So this tells for how many seconds the player has to be on air, and this player rotation speed tells with how much this rotation speed is used to control the uh, rotations of this sprite. If the value is higher, then this sprite will rotate very fast. If it is low, it will, if the value is low, it will rotate very slow. So these are all the variables that we have exposed as public. And now we have private movement key invoked false, private game object, and we check whether private player bool on ground, we check whether the player is on ground, and we check the player is jumping up. All these things are private variable. I will go into that later, but first we will start with the start method. So in a start method, what we do is we get the transform.get component of rigid body 2D. So we say get the rigid body 2D component and assign it to rig body. So this is a private variable that we exposed here, and we say rigid body dot gravity scale is 0. So when the game starts, the gravity scale will become 0 automatically, because we don't want Unity engine to take control of the uh, gravity with respect to this uh, rigid body. So we are saying make this gravity scale to 0, and we are saying we will be controlling this gravity through code. So we set this to 0, and next we have this player object. It's a game object, that's a private variable, and we are saying transform dot find player object dot game object. So we find this player object, that is this sprite. So we get the reference of the game object and we assign it to this, and we have this update method. But before going into the update method, let's pass this. We don't want to look into this. I will explain you these functions. This is very straightforward. Okay, I will explain all these functions, then I will go to update method. That makes sense. So we have the function here is ground hit. So basically we have to check whether the player is going, whether the player hits the ground or not. Then only the player can jump. It should not be like let me show you the output. While the player is jumping, and if the player is on the air, we should not allow the user to take, we should not give input to the user. It should not be like player can jump up in the air again. So currently we are giving only one jump, so that is possible only if the player is on the ground. If the player is on the air, he will not be able to jump up, and until he reaches the ground, the input for the jump will be disabled. So that's the reason we have this function called is ground hit. It's pretty simple. What we do is we iterate through all the foot trace. If you see foot trace, this is the ray property. So here we are going and we are saying raycast hit 2D result, and we are saying physics 2D dot raycast, and we are saying we are casting a ray from, for example, take this ray. We are saying, hey, cast a ray up to this much distance. So we are saying from the ray position, that is this position, cast a ray up to this much distance and check whether it hits the ground. So when we are giving this position and length, we are checking, we are also giving collision layer to check for. So collision layer to check for here is ground. So if you see here foot ray, element 1, element 2, all of them have collision layer to check for is ground. So we say cast a ray up to this much distance and check whether this ray hits the ground. If it hits the ground, you will get the hit result dot collider not equal to null. Okay, then if it is not the null, then what you can do is there is one variable that is exposed in ray property class, but that is not visible in inspector, because when you say hide in inspector attribute, this variable whatever you created as public, it won't be exposed in inspector like this, so it is hidden. So we are saying if there is a hit, then assign the hit result to the hit info that is present inside this class. So that's what we do, and we return this return foot trace of I, which ray hits the ground. For example, if this ray hits the ground, if any one of this ray, that is, if any one of this ground ray hits, then we return that ray or we return null. Same thing for is side left wall hit, we do this and we check this, and we check is side right wall hit. If any of this right wall hits the wall, so in our case let's skip it. If this ray hits the if any of this ray hits this wall, or if any of this ray hits this left wall, then we will return it. So is side right wall is basically it checks with this, and is side left wall basically it checks with this race. And there is one function called is wall hit. Basically what we do is wall hit, we are encapsulating is side left wall hit. So if it is hit, you will get this property, it won't be null, and you will return it. Or if this condition doesn't satisfy, we will check is side right wall hit, and if any of this right wall ray sorry, if any of this right ray hits the wall, then this property won't be null and it will return it. If none of these things satisfies, it will return null. So in this function we basically check whether this ray hits any of the wall, that is left side wall and right side wall, and this small function will just is a one function that tells whether you hit the wall or not. If it returns null, it means it doesn't hit any wall. And there is one more function we have here, check for ground player position. So here what we do is first we check is ground hit. So if this ray hits the ground, then this won't be null, and we are setting transform dot rotation equal to quaternion dot identity. I think this line is not needed. Sorry, I think this is not needed. We are not dealing with rotation. Okay, let's check it out. It works or not once. I think that's not needed, that line. Okay, that works good. Okay, fine. Now we are checking if the ground is hit and if the property is not equal to null. So if any of the ray hits the ground, we get this property not equal to null, and we will come to this later, okay, because this deals with player rotation, that is this sprite rotation will be handled in this condition, so we won't see this now. If it hits the ground, we are saying take jump input, we are saying hey, give the jump input, and we are using first time lean tween, that is jump up tween. So there is this class called lt description that will hold the tween description. So this is from lean tween plugin. So if you want to use lean tween, you should use dented pixel. This is the namespace that you have to include in the project, and we have this lt description jump up tween. And when we check, by default jumped up tween is not equal to null. If it is not equal to null, then on that case we are saying lean tween dot cancel game object jump tween dot id false. Basically what this function does is in lean tween you can do the tweening effect uh, from start to end by giving some set of properties. Let me explain you what that means. So let's create a new game object, sorry, new script scene, and make it as new behavior script. Okay, that sounds good. Now give using dented pixel. You can say lean tween dot value 0 sorry game object comma 0 comma 1 comma 1. So basically what we are saying is, on this game object I want to tween a value from 0 to 1 and it has to end in 1 second. So set on complete, we can give some function completed, and we can do like this. So in 1 second you will reach from 0 to 1. If you give 100 seconds, then at 0th second it will be 0, and at 100th second you will get the value of 1. After the 100 seconds are over, this function will be called. So in our case we don't want to wait for 100, we can wait for 1 second and say hi, and if you run it you will get hi message after 1 second. So this is the use of lean tween. You can do some wonderful tweening effect, and during this 1 second, for example, assume instead of 1 second I want to reach to 1 in 2 seconds, but within 2 seconds assume some condition satisfied, and you don't want to uh, run this tweening further. For example, you want initially you are setting 0 to 1 and you are saying you have to reach this in 2 seconds, but for some reasons you want to stop this before 2 seconds. Then what you can do is, in update method, if input dot get key up dot key code dot up arrow, you can say lean tween dot cancel game object bool on complete. So before 1 second, if you press up arrow, this tween whatever you started here, you are saying I want to cancel the tween whatever is there in this game object. This is what it means. So you are saying, hey lean tween, cancel any tween that happens on this game object. So now let me run this. If I don't press the key for 2 seconds, high will be called. But if in case, if I press the up arrow before 2 seconds, now high method won't be called, because in between at 1 second or sometime you press this up arrow and you cancelled it. So this is what we are doing here also. We check jump up tween not equal to null. I will tell why this will be useful. When we look at update method we will be able to understand. So we are saying take jump input. So okay, let's go here. Okay, check for player ground pose. Okay, we say take jump input. If you hit the ground, we are saying give the jump input, and set you are on ground and jumping up is false and jump up tween is null. But if you don't hit the ground, then check for rotation direction and apply rotation and do cancel jumping. Okay, so what happens here is, we will come to this function later, but we will say if you don't hit the ground, you are saying cancel the jumping. So now what we do is, if jump tween is not equal to null, then we will cancel this, and this tween will be cancelled itself completely, and we say on ground is false, jumping up is false, and jump up tween is false. And this method, check for rotation, direction, and apply rotation, is basically used to uh, control the rotation of our player object. So all these things will be called in the update method. So I will tell how this condition gets satisfied. Okay, so maybe some of the things will be little bit confusing. Okay, so what I will do is, better I will explain the update method in the next video. Currently I hope you guys understand about these common functions. Cancel jumping up will cancel your jumping, and take jump input will give the input to the user so that they can jump up when they are on the ground. And this wall left, wall right, and ground, ceiling, hit, all this helper function will tell whether any of the rays hit the wall, ceiling, or ground. So these are all the helper functions that we have. Now we are going to use this function in update method to process our player movement and jumping. I think nothing big is happening over here. It's all these functions, whatever I explained it, I am going to call it here, but with some conditions which I will explain you in the later video. I think this video is kind of pretty big, so I don't want to continue further and confuse you guys. So thanks for watching. I will catch up you guys in the next video. Bye.